Hey there, space cadets! Ever looked up at the night sky and thought, why is there something rather than nothing? Yeah, me too. It's a question that's haunted philosophers and scientists for centuries. Why does the universe even exist? I mean, seriously, wouldn't it be easier if there was just nothing? We're diving headfirst into the cosmic abyss to explore the mind-blowing theories about the universe's existence. Buckle up, because things are about to get seriously existential. From the Big Bang to quantum weirdness, we're leaving no stone unturned. Get ready for a wild ride through the cosmos as we try to unravel this ultimate cosmic mystery. We'll be your guide through the mind-bending world of science and philosophy, exploring ideas that'll make your head spin faster than a black hole. So, grab your thinking caps, and let's embark on this epic quest to answer the mother of all questions. Why in the universe is there a universe? Before we dive into the why, let's talk about the where. We live on a planet called Earth, orbiting a pretty average star we call the Sun. Our Sun? Just one of billions in the Milky Way galaxy. And guess what? Our galaxy is just one of billions upon billions scattered across the vast cosmic sea. The universe is mind-bogglingly huge, ancient, and full of mysteries. It's enough to make you feel both incredibly insignificant and strangely connected to everything all at once. Talk about a cosmic paradox. But here's the thing. Even though we're just a tiny speck in the grand scheme of things, we humans have this incredible ability to ask big questions. And the question of why the universe exists is about as big as it gets. So, how do we even begin to wrap our heads around something so vast and profound? Well, we turn to science and philosophy, our trusty tools for navigating the great unknown. Think of the universe as this grand cosmic play, and we're trying to figure out the plot. Scientists are like the detectives looking for clues in the laws of physics and the echoes of the Big Bang. Philosophers, on the other hand, are like the playwrights exploring the deeper meaning and purpose behind it all. We'll be looking at some seriously trippy theories like the idea that our universe is just one of many in a mind-blowing multiverse. We'll also delve into the bizarre world of quantum mechanics, where things can exist in multiple states at once. And of course, no exploration of the universe's existence would be complete without tackling the Big Bang Theory, the prevailing scientific model for the universe's origin. Get ready to have your minds blown wide open. Alright, let's rewind the cosmic clock way back, like 13.8 billion years back. Before time and space as we know it existed, there was this tiny, ultra-hot and dense point called a singularity. Imagine all the stuff in the universe crammed into a space smaller than an atom. That's the singularity in a nutshell. Now, we don't know exactly what caused this singularity to exist in the first place. It's like the universe's ultimate magic trick. But we do know that something pretty epic happened next, the Big Bang. Contrary to its explosive name, the Big Bang wasn't some fireworks display in a pre-existing space. It was the rapid expansion of space itself, stretching and cooling as it went. Think of a balloon being inflated at an unimaginable speed, that's more like it. Section 2, the Cosmic Explosion. As the universe expanded and cooled, energy transformed into matter, like a cosmic game of alchemy. First came the fundamental particles, quarks, electrons, and the gang. Then these particles started to clump together, forming protons and neutrons. Eventually things cooled down enough for atoms to form, mainly hydrogen and helium, the simplest elements in the universe. This early universe was like a giant cosmic fog, but within this fog, the seeds of galaxies and stars were already being sown. Gravity started to pull these clumps of matter together, forming vast clouds of gas. These clouds collapsed under their own weight, igniting nuclear fusion and giving birth to the first stars. These stars, much larger and hotter than our sun, became the cosmic furnaces that forged heavier elements like carbon, oxygen, and even iron. Now, fast forward billions of years and here we are, sitting on a planet orbiting a star that was formed from the remnants of those ancient stellar explosions. Pretty mind-blowing, right? But how do we know all this actually happened? Well, we have some pretty compelling evidence like the cosmic microwave background radiation, the faint afterglow of the Big Bang. Imagine the universe's baby picture, a snapshot of the universe when it was just 380,000 years old. And then, there's the expansion of the universe itself. By observing distant galaxies, astronomers have found that they're moving away from us, and the farther away they are, the faster they're receding. It's like the universe is still expanding from that initial burst billions of years ago. The Big Bang Theory is the best explanation we have for the universe's origin, but it still leaves us with some pretty big questions, like, what existed before the Big Bang? What caused that initial singularity to come into being? And what were the conditions that allowed our universe, with its specific laws of physics, to emerge? These are questions that science alone might not be able to answer fully. But that's where our human curiosity and thirst for knowledge kick in. We keep searching, keep questioning, and keep exploring the cosmos for clues. The Big Bang might be the beginning of our universe's story, but it's not the beginning of the story of existence itself. So buckle up, because things are about to get even weirder as we dive into the world of quantum mechanics and the possibility of a multiverse. Hold on to your hats, folks, because we're about to enter the twilight zone of physics, the quantum realm. This is where the usual rules of reality go out the window and things get seriously strange. Forget everything you thought you knew about how the world works, because down here, things can be in two places at once, particles can teleport, and cats can be both dead and alive. Quantum mechanics is the study of the super tiny, the world of atoms and the particles within them. And at this scale, things get seriously weird. Imagine a reality where the very act of observing something changes the outcome, or where particles can be linked across vast distances, acting like they have some sort of cosmic telepathy. It's enough to make your head spin, but trust me, it's also incredibly exciting, because the weirdness of the quantum world might hold the key to understanding how something can come from nothing, the ultimate cosmic magic trick. Now, imagine the early universe just moments after the Big Bang. Everything is incredibly hot, dense, and chaotic. At this scale, quantum mechanics reigns supreme, and things are popping in and out of existence like a cosmic game of whack-a-mole. This chaotic sea of quantum weirdness is what physicists call quantum foam. Think of it like this. Imagine a pot of boiling water. The water represents the fabric of space-time, and the bubbles are quantum fluctuations, tiny bursts of energy that appear and disappear in the blink of an eye. Most of these bubbles pop out of existence as quickly as they form. But here's where things get interesting. Some physicists believe that under the right conditions, these quantum fluctuations could be powerful enough to create a universe. It's like one of those bubbles in the boiling water suddenly expanding to become an entirely new pot. But how can you get something from nothing, you ask? Well, quantum mechanics has a few tricks up its sleeve. One of the most mind-bending ideas is the concept of zero-point energy or vacuum energy. This is the idea that even in a perfect vacuum where there's supposedly nothing, there's still a tiny amount of energy present due to the constant fluctuations of quantum fields. It's like the universe is constantly borrowing energy from itself, creating these virtual particles that pop in and out of existence, only to disappear again before they can be detected. It's a bit like borrowing money from a bank and paying it back so quickly that no one even notices. Now, some physicists believe that under extreme conditions like those present in the very early universe, these quantum fluctuations could be amplified, providing the energy needed to kickstart the Big Bang. The idea that the universe could have emerged from a quantum fluctuation is certainly mind-blowing. It suggests that our universe might be just one of many universes bubbling up in a vast cosmic sea of potentiality. It's like the universe is a giant cosmic lottery, and we just happen to be living in one of the winning tickets. But hold on, doesn't this violate the law of conservation of energy, which states that energy can't be created or destroyed? Well, not necessarily. Some physicists believe that the total energy of the universe, including the positive energy of matter and the negative energy of gravity, might actually add up to zero. If that's the case, then the universe could have emerged from a state of zero energy, meaning no energy was actually created or destroyed, just transformed. Talk about the ultimate cosmic free lunch. Of course, these are still just theories, and there's a lot we don't know about the quantum world and the very early universe. But the idea that our universe could have emerged from a quantum fluctuation is a tantalizing possibility, and it highlights just how weird and wonderful the universe can be. So, we've journeyed through the mind-bending world of quantum mechanics, where particles pop in and out of existence like they're late for a cosmic rave. But what if I told you there's a whole other level of weirdness, a realm even deeper than the quantum realm? Buckle up, Buttercup, because we're about to dive into the seriously trippy world of string theory. String theory is like the rebellious teenager of theoretical physics. It's full of big ideas, wild possibilities, and it hasn't quite cleaned up its room yet. It's a work in progress, but it has the potential to revolutionize our understanding of the universe, including the very question of why it exists at all. Imagine, if you will, that everything in the universe, from the smallest particles to the largest galaxies, isn't made of point-like particles but of tiny, vibrating strings of energy. These strings are so small, they're way beyond our current ability to observe directly. Think of them like the subatomic equivalent of guitar strings, except instead of producing music, they create all the particles and forces that make up our reality. Now, just like different vibrations on a guitar string produce different musical notes, different vibrations of these cosmic strings create different types of particles. An electron might be a string vibrating one way, while a quark might be a string vibrating another way. It's like the universe is a grand symphony, and the particles are the notes played on the cosmic strings. But here's where things get really interesting. String theory suggests that there might be more than just the three spatial dimensions that we experience in our everyday lives: up, down, left, right, forward, backward, and one dimension of time. Instead, string theory proposes that there could be as many as 10 or even 11 dimensions, all curled up and hidden within the fabric of spacetime. It's like our universe is a giant cosmic tapestry, and we're just ants crawling around on one tiny little thread, oblivious to the vastness of the other dimensions right beneath our feet. Section 3. Extra dimensions and hidden realities. Now, I know what you're thinking. If these extra dimensions exist, why can't we see them or interact with them? Well, string theory suggests that these extra dimensions are incredibly small, curled up at a scale far smaller than even the tiniest subatomic particles. It's like trying to see a single atom on the surface of a basketball. It's just too small to perceive with our current technology. But even though we can't directly observe these extra dimensions, they could still have a profound impact on our universe. The way these extra dimensions are shaped and curled up could determine the fundamental constants of nature, like the strength of gravity or the mass of an electron. It's like the universe is a giant cosmic music box, and the shape of these extra dimensions determines the tune that our universe plays. Unifying the forces: a cosmic quest. String theory aims to unify all fundamental forces into a single framework. It bridges general relativity and quantum mechanics. These theories don't always fit together. String theory offers a possible solution. Describing particles as vibrating strings could reconcile them. It's like finding the missing piece of the puzzle. String theory offers a glimpse into a stranger, wonderful universe. Section 1. Beyond our cosmic horizon. Hold on to your hats, cosmic explorers, because things are about to get even weirder. We've talked about the Big Bang, quantum fluctuations, and even the mind-bending world of string theory. But what if I told you that our universe, vast and mind-boggling as it is, might just be one of many universes in a grand cosmic multiverse? Yeah, you heard that right. A multiverse. It's like the universe has a subscription to cosmic cable and we're stuck on just one channel. The idea of a multiverse has been around for a while, but it's gained serious traction in recent years, thanks to advances in cosmology and theoretical physics. Imagine, if you will, an infinite expanse of space-time filled with countless bubbles, each one a universe unto itself, with its own laws of physics, its own constants of nature, and maybe even its own versions of us. Talk about a cosmic identity crisis. One of the most popular multiverse theories is the idea of eternal inflation. Remember how we talked about inflation, that period of rapid expansion in the very early universe? Well, some physicists believe that inflation never really stopped. It's like the universe is on a sugar rush that never ends. In this scenario, our universe is just one bubble in a vast cosmic sea of inflating space-time. As this sea of energy expands, new bubbles form, each one a new universe with its own unique properties. It's like a cosmic bubble bath with universes popping up all over the place. Some of these universes might be similar to ours, with stars, galaxies, and maybe even planets teeming with life. Others might be radically different, governed by laws of physics that would make our heads spin faster than a black hole. The possibilities are literally endless. Another mind-bending multiverse theory emerges from the weird world of quantum mechanics. Remember how we talked about quantum superposition, where particles can be in multiple states at once until we measure them? Well, some physicists believe that every time a quantum measurement is made, the universe splits, creating a separate timeline for each possible outcome. It's like the universe is playing a cosmic game of Dungeons and Dragons, and every time we roll the dice, a new parallel universe branches off. In one universe, you might be a rock star, while in another, you're a world-renowned chef. And in yet another, you might be a talking cat. The possibilities are truly mind-boggling. This many-worlds interpretation of quantum mechanics is a controversial one, but it's a fascinating thought experiment that highlights the strangeness of the quantum realm and the possibility that our reality might be just one of many. Can we ever prove that a multiverse exists? These other universes would be outside of our own observable universe. Some physicists believe we might find indirect evidence in the cosmic microwave background radiation, the afterglow of the Big Bang. If our universe collided with another, it might have left a faint imprint, like a cosmic bruise. The search for evidence of a multiverse is still in its early stages, but it's a quest that could revolutionize our understanding of the universe. Okay, so we've bounced around the universe like a cosmic pinball, exploring mind-blowing theories from the Big Bang to a potential multiverse. But let's take a step back for a second and ponder this. What if the reason our universe exists is simply that we're here to observe it? Welcome to the mind-bending world of the anthropic principle. Don't worry, it's not as self-centered as it sounds. The anthropic principle basically says that the universe must be compatible with the existence of observers like us. In other words, if the universe were any different, we wouldn't be here to ask why it exists in the first place. Think about it, the fundamental constants of nature, like the strength of gravity or the mass of an electron, are so finely tuned that even the slightest tweak would result in a universe incapable of supporting life as we know it. It's like the universe is a recipe, and if you change even a pinch of one ingredient, the whole thing falls apart. Now let's dive headfirst into the realm of pure speculation with the simulation hypothesis. What if, and stay with me here, our reality isn't real at all? What if we're all just characters in a super advanced computer simulation, like a cosmic version of The Sims, but with way better graphics? I know, it sounds like something straight out of a sci-fi movie, but hear me out. Some philosophers and scientists argue that if we reach a point where technology is advanced enough to create realistic simulations of entire universes, it's plausible that we're already living in one. Think about it. Our most advanced simulations are already so realistic they can fool the human eye. What happens when those simulations become indistinguishable from reality itself? Does it even matter at that point? Now let's get philosophical for a moment. Does the universe have a purpose? Is there some grand cosmic plan, or is it all just a random accident? This is a question that's been pondered by philosophers and theologians for centuries, and there's no easy answer. Some believe that the universe was created with a specific purpose, whether that's to provide a home for life, to allow for the evolution of consciousness, or to simply exist for its own sake. Others believe that the universe is indifferent to our existence, a vast and uncaring void in which we're just along for the ride. Ultimately, The question of whether or not the universe has a purpose might be beyond our ability to answer. But that doesn't mean we should stop asking. The search for meaning and purpose is a fundamental part of the human experience, and it's what drives us to explore, to question, and to try to understand our place in the cosmos. So, here we are, at the end of our cosmic journey. And what have we learned? Well, we've explored some of the most mind-blowing theories about why the universe exists, from the Big Bang to quantum fluctuations, from string theory to a potential multiverse. We've even dipped our toes into the philosophical waters of the anthropic principle and the simulation hypothesis. But the truth is, we still don't have a definitive answer to the question of why the universe exists. And that's okay. The universe is full of mysteries, and the more we learn, the more we realize we don't know. The important thing is to never stop asking questions, to never stop exploring, and to never stop being amazed by the sheer wonder and mystery of the cosmos. The universe is a vast and incredible place, and we're incredibly lucky to be a part of it, even if we don't fully understand it. So, keep looking up at the stars, keep asking the big questions, and never stop exploring the infinite possibilities of the universe. So, we've traveled to the edge of the universe and back, explored the mind-bending world of quantum mechanics, and even contemplated the possibility that we're all just living in a giant computer simulation. Talk about a wild ride. But where does that leave us? Well, for starters, with more questions than answers. And that's okay. The universe isn't some cosmic crossword puzzle with a single solution. It's more like a giant, ever-evolving jazz improvisation full of unexpected twists, turns, and mind-blowing solos. We've explored some of the most compelling theories about why the universe exists, from the explosive birth of the Big Bang to the ethereal whispers of quantum fluctuations. We've pondered the existence of hidden dimensions, parallel universes, and even questioned the very nature of reality itself. But ultimately, the question of why the universe exists might be a question for the ages. It's a question that has haunted philosophers and scientists for centuries, and it's a question that might not have a definitive answer. At least not one we can fully grasp with our current understanding of the cosmos. But here's the thing, even if we never fully unlock the secrets of the universe's existence, the very act of asking the question, of searching for answers, is what makes us human. It's our insatiable curiosity, our drive to explore the unknown, that sets us apart from all other creatures on this pale blue dot we call home. In a way, the universe's existence is reflected in our own quest for knowledge. Just as the universe is constantly expanding, evolving, and revealing new wonders, so too are our minds capable of infinite growth and discovery. The more we learn about the universe, the more we realize how much we don't know. But instead of being daunted by this vast ocean of unknowns, we should be inspired by it. It's a reminder that there's always more to learn, more to explore, and more to discover. So, what's the point of it all? Why does any of this matter? Well, in the grand scheme of the cosmos, our individual lives might seem insignificant, but that doesn't mean they're meaningless. We are all part of this grand cosmic dance, connected to every other living thing in the universe by the intricate web of space-time and the fundamental laws of physics. The very atoms that make up our bodies were forged in the hearts of dying stars, scattered across the cosmos in supernova explosions, and eventually came together on this tiny planet to create something truly remarkable. Life. We are, in a very real sense, children of the stars, and our existence is a testament to the universe's incredible ability to create order out of chaos. So the next time you find yourself staring up at a starry night sky feeling small and insignificant, remember this: you are a part of something much bigger than yourself. You are a part of the universe, just as the universe is a part of you. And that's a pretty amazing thing to be a part of, wouldn't you say? The universe is full of wonder, mystery, and endless possibilities. It's a place where the impossible can become possible, where the laws of physics dance on the edge of our understanding, and where the only limit to our exploration is the scope of our own imaginations. So, keep looking up at the stars, keep asking the big questions, keep searching for answers, even if those answers lead to even more questions. The universe is waiting to be explored, and who knows what incredible discoveries await us just beyond the horizon of our understanding. The journey to unravel the mysteries of the universe is a never-ending one, but it's a journey worth taking. So, buckle up, fellow cosmic explorers, and enjoy the ride. The universe is vast, strange, and endlessly fascinating. And who knows, maybe someday, we'll finally unlock the secrets of its existence. Until then, keep exploring, keep questioning, and keep looking up.